Hi guys, today we will talk about moment of a force and specifically we will talk about scalar formulation. So firstly, what is the moment of a force? It is also called torque, and that in scalar formulation is a measure of the tendency of a force to rotate an object about a point or axis. Imagine here we have some beam, and usually beams are often used to bridge gaps in walls, and we have one point force F with a distance dA from the point A. So we need, in order to determine moment about point A, we need to multiply F with the perpendicular distance, which is in this case dA. So we need to know what the effect of the force on the beam will have on the supports of the beam. So the question here is, what do you think is happening at points A and B? So we will have a torque at point A, which will be F times dA, which is a perpendicular distance to the point A, but also we will have moment at point B, which will be F times dB in this case, which will be again perpendicular distance. So scalar formulation will be m is equal F times d. M is a moment, and since that we have a force which is usually in units Newton, pounds, etc., and we have a distance which is meter, centimeter, decimeter, inch, foot, etc., we will have a moment, and the units will be Newton meter or pound feet or kilonewton meter, etc. So d is a perpendicular distance from the point or axis to the line of action of the force. Now, if we have something like this, so this is a 2D case, the magnitude of the moment is what we said earlier, m naught is equal F times d, and here we have the perpendicular distance, and in 2D direction of m naught is either clockwise or counterclockwise depending on the tendency for rotation. For you, let's assume counterclockwise is something which we call as a positive moment, and if it is a clockwise, that is a negative moment minus m naught. So in case that we have a force, for instance F, and we have some point O, and we want to determine what will be the moment at point O from the force F, then we need to determine, and it is easier to split this force F into two components, one which will go in x direction and the second one which will go in y direction. So our moment will be m naught is equal Fy times A, which is perpendicular distance to the O, and in this case Fy will be counterclockwise, and we have Fx, which is times B, perpendicular distance for Fx, but it will go clockwise, and that's why we have that m naught is equal Fy times A minus Fx times B. So note the different signs on the terms. The typical sign convention for a moment in 2D is that counterclockwise is considered positive, and we can determine the direction of rotation by imagining the body pinned at O and deciding which way the body would rotate because of the force. So let's do this example. If we have some beam here which is subjected to a force of 4 kilonewton, and we have some angle theta, and it is said for us that theta is 45.3 degree, and we need to determine the moment at point A. So what we have to do, we need to split firstly the force of 4 kilonewton into two components in x and y direction. In x, it will be 4 times cosine of 45, and to come to the point A, we will have a perpendicular distance for this horizontal projection of the force 0.45, and it will go counterclockwise, which means that it is a positive sign, and we have 4 times sine 45 times 3 meter, and in this case this moment will be clockwise. So 4 cosine 45 times 0.45 and minus 4 sine 45, which will be y projection of force 4 kilonewton times 3 meters, which is a perpendicular distance, and it will give us minus 7.21 kilonewton meter, which indicate that our moment is clockwise. So that was the end for today. Thank you for your attention and talk to you soon. Bye.